In this video, we're going to talk about how to find the volume of composite solids. So a composite solid is two or more solids that form a new solid, either by addition or subtraction. So if we take a look at this example here, it looks like we have a hemisphere that is basically stacked on top of a cylinder. So since there are two solids here being added together, this is a composite solid. In our second picture here, it looks like we have a rectangular prism, but it looks like the cone is being cut out of it. So we're subtracting the cone from it. Since we're still working with two solids, we still call this a composite solid. Stacking solids is going to increase volume and require addition. Removing solids will decrease the volume and require subtraction. And then you'll see here are all of our volume formulas that we may need to use throughout this lesson. All right, let's look at some examples. Make sure you have your calculator. Number one, the cylinder and hemisphere below form a composite solid. If the height of the cylinder is 8 inches and the radius of the cylinder and hemisphere is 3 inches, find the total volume of the composite solid in terms of pi. So I would suggest trying to keep your work organized for this. So pick a shape to start with. So let's say I start with the hemisphere and find its volume. Then clearly label, okay, here's my cylinder volume, and make sure we're just copying our formulas over correctly. So volume of a hemisphere is 2/3 pi r, which is 3 cubed. Cylinder is going to be volume equals pi. The radius of the cylinder is also 3, and its height is 8. So for the hemisphere, let's type that into our calculator. We're doing in terms of pi, so I will not be putting pi in the calculator. So I have 2/3 times 3 cubed. So the volume of the hemisphere is 18 pi. For the cylinder, again, do not put pi in the calculator. We're still doing in terms of pi. So 3 squared times 8, and I get 72 pi. Finally, at the end, these shapes are being stacked, so the total volume is going to be 18 pi plus 72 pi. Think about 18 and 72 as coefficients that we can combine. When we add them together, we get 90 pi, and then our units for volume are always inches cubed, and that would be our answer to this question. Okay, number 2, Carlos purchases a 12-foot by 8-foot rectangular tent for a party. The legs of the tent are 12 feet tall, and the roof is in the shape of a rectangular pyramid with a height of 3 feet. What is the volume of the tent in cubic inches? All right, so if we look at this, the tent is 12 by 8 at the bottom, and then the actual height of that part of the tent is 10. Then the roof is a separate shape. That's the rectangular pyramid with the height of 3. The key in here is that if I zoom into my picture, where I have this 12 feet at the bottom, notice the pyramid at the top is going to share that measurement. And that's going to be the same case over here with the 8 feet on the right-hand side. That's going to be key for this. So if we look at this, the tent is in the shape of a rectangular prism. And then we're going to find the volume of the pyramid, and then we will add them together since they are stacked. So prism formula is area of the base, so that's 12 times 8 times the height. So 12 times 8 times 10. So the volume of the main part of the tent is 960. Now we're going to find the volume of the pyramid. It's 1/3 area of the base, so 12 times 8. And the height of the pyramid is 3. So in my calculator, I'm doing 1/3 times 12 times 8 times 3. And we're looking for our total volume here. So we're going to be adding 960 plus 96 together. So 1,056 cubic feet for our total volume of the tent, including the roof. Number 3, a cube has edges of 7 inches. A right circular cone shape is cut out of the cube and has the same height as the cube. That's going to be key here as I go through this, that the height is the same. The radius of the cone is 2 inches. Find the volume of the remaining solid to the nearest tenth of a cubic inch. So we're starting out with a cube. we're cutting out a cone and we're going to find the volume of what remains. So a key fact about a cube is that all of the sides are congruent squares. So it only gives us this 1/7 inch at the bottom, but I know this is 7 inches. I know this is 7 inches. And if you notice right there, that means the height of the cube is 7 inches. Well, it tells you the cone has the same height as the cube. So I know that this height is 7 inches as well. So I think we have all of the information we need to actually calculate now. So the cube is a type of rectangular prism. So you're using this formula, area of the base times height. So this is 7 times 7 times 7. And the volume of the cube is 343. For a cone, our formula is 1/3 pi r squared h, so 2 squared times 7. And I'm going to be putting this in my calculator. We are going to get a decimal here. So the volume of the cone is 29.32153. I'm going to write all of these decimals in here and not round yet, because it asks us to find the volume of the remaining solid. So when I find that, that's when I'm going to actually round. So I'm going to take 343, subtract that volume of the cone, and the volume of the remaining solid to the nearest tenth is 313.7 inches cubed. Keep in mind here that since we were carving out or cutting out this cone shape, our volume is decreasing rather than increasing like the first two examples. All right, for our last example, a greenhouse is being constructed and can be modeled by a half cylinder on top of a rectangular prism that is 15 feet by 10 feet by 9 feet. Find the total volume of the greenhouse to the nearest cubic foot. All right, so we have a rectangular prism and we have a half cylinder. That's a little different, and I'll talk about what we're going to do to the formula for that. So prism formula, area of the base times height. Cylinder is normally pi r squared h, but we want half of it, so we're just going to multiply by a half. All right, the prism volume looks pretty simple to calculate here. So the base is 10 times 15, or the base is 10 times 15. The height is 9. You could think about volume of a rectangular prism as length times width times height as well. That would be perfectly fine. So the volume of the prism part of the greenhouse is 1350. Now let's talk about the half cylinder. The radius, we have to identify. Notice the half cylinder has nothing written on it. So I'm going to copy over the 15 feet, copy it up, the 10 feet, copy it up, and see if that will help me. So now at least there's numbers near the actual cylindrical part. So the radius is half of the circular part. So the radius is going to be 7.5. The height can be tricky. Remember the height of a cylinder. Think about a can of soup. Okay, that's a cylinder shape. The height is how far apart the two circular bases are. So the height is really going to be this 10 feet because that's connecting these two semicircles here. And now I'm going to put that in my calculator to figure out the volume of that half cylinder. All right, so that volume came out to be 883, and then we have a whole bunch of decimals that follow. And we are adding volume here, right? Our composite solid is getting bigger because they're being stacked on top of each other. So we're looking to the nearest cubic foot, so we're going to add those two numbers together. And to the nearest cubic foot basically means to the nearest whole number. So this is going to be 2,234 cubic feet as our total volume. Okay. So again, with composite solids, just a reminder, if they are being stacked, you're going to add the individual volumes. If they're being removed, you're going to subtract them.